All right, let's look at exponential functions. So g of x equals 1/2 the x. So I'm going to do 1/2 to the -2, 1/2 to the -1, 1/2 to the 0, 1/2 to the 1, and 1/2 to the 2. You got a couple ways you could do this. Okay, let me put parentheses around this. All right, one way is you could just do it like 1/2 to the exponent of -2. I don't know why I didn't put my, so it's 4. I could do, or you could go to, I'll show you the way I would do this, y equals, and go to alpha y equals, get that fraction, 1/2 to the power of x, and then do second table or second graph, which is table, and then we could just fill these in. So -1's 2, 0's, that's 1. Anything times you have to the 0 power, it's 1, and then 1/2 and 1/4. Okay. Now let's plot these points. So -2 is at 4. -1 is at 2. 0 is at 1. 1's at 1/2. 2's at 1/4. And so I want to show you the graph of this because we got to talk about the asymptote here. This one does have an asymptote. We haven't talked about that yet. So this is what we call an exponential decay problem. It's decaying because it's going down as x increases, y is decreasing. And what happens is it does not cross the x-axis. So it's going down and it's approaching the x-axis, but it'll never cross it. So this is your graph. Now the asymptote's the function, which would be an asymptote at y equals 0. So asymptote at y equals 0. And that will always be y equals 0 unless they transform it, which we'll talk about that in another lesson. Now, the domain, how far left does it go? Will it go forever left? How far right will it go? It'll go forever right. Range, how far down? Will it approach 0 but never touches it? So we're going to say 0, not including 0, but it just goes all the way, everything up until 0, okay? So it goes down forever and ever. So 0 is like a boundary, but it never touches it. So that's why we have a parenthesis. How far up does it go? It goes up to infinity. So there's your domain range.